I wanted to share something in this devlog that I thought was pretty cool. I've been messing around with King's Claim, as you know. If you've been watching, I guess I won't bother playing again right now, but I started to brainstorm what I needed to do to figure out the AI player stuff. So, well, maybe I will show you something real quick. Let's start up the game, see if it's running. Okay, so we're gonna load this up here. Start game. Okay, same thing here. Start game. These two are gonna join each other, and I don't know if this is still working, but anyway, yeah, it doesn't really look like it's working. So you've got red and a blue castle. You've got a quarry. If I toggle the debug display, you can see the other quarry over here. And when the debug display is turned on and this is actually running, what you'll see is that the workers will kind of go back and forth, and little yellow X's will be placed on the ground where one of the two players has issued jobs, like walls to be built. I guess that's not working. I'm not sure what I did to break it. But the point of all this is that there was no strategy to how the AI was placing jobs out there to have walls built. So as a result, that's not what I intended. Anyway, as a result, it was very haphazard. It was all over the place. It wasn't very good. And now I've totally messed up my video here. So I wanted to start working on the AI for the CPU. And one of the things I needed to do was have some way of the of an enclosed area to indicate that, gosh, what am I trying to say? I needed some way to know that if an area had been totally enclosed by walls, that I could detect that it had been enclosed, and then give credit for that enclosed area to the player who enclosed it. Why? Because the more land that you kind of claim in this game, the more workers you get. And so I wish I could show you something. I don't quite have that ready, but I basically worked with an agent to figure out how to code that. And I did some research on different ways of an algorithm to do that. And what I found is that a common way to do it is to use a flood fill. So let's imagine that you had this castle here, and let's say that you had walls completely around it, right? What you would do is you would, within those enclosed walls, you would start at the castle and you would say, flood fill this area with a maximum number of cells to check. And if you run out of, if you fill the entire area and it's enclosed, it doesn't leak out, then basically that area is enclosed, because if it wasn't enclosed, it would leak out and go everywhere, right? But if it is enclosed, then treat that place as if it is enclosed. And that's what I got done. I can then later give a player credit for that enclosed area if it's enclosed. So what I had to do first, what I had to do first was write a quick algorithm to do a flood fill given a starting point. And here's what I gave the agent. Now I did this outside the recording because I didn't know how long it was going to take, and I didn't want to bore you all with a flood fill, but here's the prompt I did. I want you to write a Ruby module called tinyfill. So I have this little library that I've published called tinyfill that includes a method with the following signature: detect. I later renamed this to fill. I'll show you in a little while. To detect, and it takes a 2D map, a starting X coordinate, a starting Y coordinate, and a max search. Max search is the number, well, I guess it's explained below. This module will implement a flood fill algorithm for games in order to detect enclosed areas. So the input, the map is a 2D array of booleans where true indicates a border, in this case a wall, right? And false indicates an open cell. Start x is the x coordinate where the search starts. In my case, that would be the x coordinate of the castle you're searching from. Start y is the y coordinate of the starting point of the search, which is the y point of the castle. And max search is the maximum number of cells to check. Why is that useful? Well, you don't want to flood fill the entire map and give the player automatically give the player credit for the entire map. That wouldn't work. So what I need to do is define some kind of maximum area, maybe like, I don't know, a 5 by 5 walls or 10 by 10 or something, so that the maximum area that it will search is, say, I don't know, 25 or 100 cells. And if it doesn't find a totally enclosed area within there, then the walls are like too big of an area. And so the player will have to break that up. Here we go. As each false cell in the map is investigated, its value should be set to true to indicate that it's been searched for the algorithm. This will also be used as part of the return value when an enclosed area is found. Note, hitting the outer edges, the top, bottom, left, or right of the map can be treated like a border. So, for example, if a player enclosed like this bottom corner completely, then I can give the player credit for everything inside of there, within the max search, of course. If the detect method completely runs out of cells to traverse before reaching the max search number of cells investigated, then an enclosed area has been found before max search, right, before max search cells. In this case, the detect method should return a 2D map/array, and the caller will treat all true cells as part of the enclosed area. If detect method searches max cells and still has more to explore, then an enclosed area is not considered to have been detected. Okay, so that basically does a flood fill, and as it's doing the flood fill does a breadth first search. You can look up what that means if it's not a term you know, but a breadth first search basically goes out kind of in every direction in this case, looking for cells that have not yet been investigated. Anyway, and then so like I was chatting with the AI and said like, hey, if you were to implement this, tell me what your implementation would be so I can review it. And it thinks for a while and it gives me this algorithm. And I was like, yeah, that sounds, about right according to what my previous research was. But I didn't have it actually build it. I left this in planning mode. So we were just talking, and then I'll scroll to the bottom here. What I had it do, let's see. Oh, the very last thing I had to do was write some documentation to explain to my future self how to invoke this method. It's pretty simple, but there's that. But the other thing I had it do, I actually wrote the code by hand. And let's see. I guess I don't really have to show you the code because it's not like that exciting. But I will show you where it's published. Let's see. I'm going to look this up off screen and then I'll bring it over. Okay, here we go. So I write code in Ruby primarily, and all this stuff is in Ruby. So on Ruby Gems, which is a place to publish publicly published libraries, shared libraries, I created this gem called TinyFill. And if you go from there and you click home page, it'll take you to the GitHub page that has the code, and then it just basically tells you just look at the one file because it's just one file. It gives you an example of what a map looks like. And in this case, we have like this enclosed corner where the trues are. You can see here. And so like this area is enclosed, the upper left, and then this outer edges. And then I say start at 1, 1, which would be this one, and search a maximum of 10 cells, and then it returns true for flood filling the top left section. Okay, so here's the code. So it's not a lot of code. It's less than 100 lines to do this flood fill algorithm. And what it does is, let me check this, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So it goes from a starting cell, say here, and then it looks at each of the 8 adjacent cells, up, right, or I'll call it north, northeast, east, southeast, south, southwest, west, and northwest. And it says, hey, mark my current cell as I've searched it, and then add each of the adjacent cells to a queue of things to check. And then it goes through the loop, and it goes to the top and says, okay, now start again with this cell and look at all the adjacent cells and add those cells to the queue of things to check as well. It tries to do some smart things by like marking the stuff that's going into the queue as already searched, so that it doesn't check a cell more than once, that kind of thing. But anyway, point is, I wrote the code by hand this time rather than vibe coding it, because it was a pretty simple loop. And then at the end, here's the prompt I sent it after I thought I had a working version. Oh, actually, no, I take that back. I asked it to look at my code because I had a bug that I couldn't quite figure out. And I was testing it and it didn't work. And so I said, I think this code actually does the implementation of the algorithm, but can you check the implementation to tell me if anything is missing? Now, I already knew there was a bug because in my testing, the code was wrong, or I should say the result was wrong, but I wasn't quite sure what was happening. Well, so it reads through the code and it compares the code that I wrote to the ideal or the idea that it had come up with for how it might implement it. And you can read through this stuff here if you want to pause and read, but under the issues found, this was the main thing, right? So it correctly called out that that I was using the same starting point every single time, instead of starting here and searching adjacent and then moving here and searching adjacent. What it was doing is just starting here, searching adjacent, and then it would start here again and search adjacent, and so it would never move. So it wasn't actually filling. So it correctly called out that I was using the start X and start Y on every single iteration, rather than moving from cell to cell to cell to do the breadth first search. It found a case where I was returning incorrectly. It also, at the time, found that I was doing what it called inefficient queuing, which was, I had a bug where I was queuing the same cell over and over again at times. So like I would start here and queue the 8 adjacent cells, and then I would like go up and queue the 8 adjacent cells, which included several cells that had already been investigated. And so it was like double checking a bunch of cells. And then like there was a couple of minor things. I had some debug statements, and I decided to change the name of the method from detect to something else. But anyway, it called all that stuff out. And then I iteratively fixed the bugs. This one right here was the main one that was actually keeping the flood fill from working, and then I fixed the inefficient queuing bug just so that the algorithm was still correct with inefficient queuing, but it was much faster when I wasn't doing double work. And then anyway, so I iterated, and I eventually got it working, and then I just asked it to write the documentation at the top of the file, so that so I didn't have to write it, basically. And so it wrote something very close to this. I modified this and trimmed it down a little bit, so this is the final version. But anyway, that's the devlog for today. Basically, I needed to work on something that was like a step toward building a computer AI that can play King's Claim on its own. And one of the pieces I needed was a flood fill algorithm for detecting enclosed areas. So I did 2 things. So rather than purely vibe coding like I often do for this project, I talked to the AI to say, hey, what are common ways of solving this? What are some of the trade-offs? It basically said like there was one main way that it's done for like 2D games, like the one I'm building that are on grid worlds like this. And then there's different versions for like if you were working with either 2D or 3D space with coordinates or a graph or something like that, where you had to detect if something was enclosed by edges or faces of a 3D object, something like that. And of course, in my case, 2D game, so I just needed the really simple flood fill. So after I understood that, that's when I was like, hey, give me your plan for how you would implement this. I read this, and this pretty much mapped onto like how I was thinking of doing it. And I basically used this as the template and said, yeah, that feels right to me. I think that would work. I could have at this point probably just asked the AI to write it, but it's something where, you don't want the AI to do everything for you all the time, especially for these like common and reusable algorithms. It's really useful to know how to do them. But what I did use the AI for this time is to come up with a plan to identify which algorithm I should use for detecting enclosed areas. And then I also had it double check my work. Like when I ran into a bug, I was like, hey, read my code and, can you tell me what seems to be missing? And it called out where my bugs were, and it said where I made the mistakes. That was great because not only was this not that hard and I could have done it by hand, but I did most of it by hand and then use the AI to fill in the gaps in my knowledge or to double check my work to make sure, hey, I have a bug, like, can you help me find it? And what I resulted in, or what I wound up with, was a library that was, pretty close to hand coded, except I kind of had the help of the AI to fix the bugs. So anyway, that's a little different than the previous devlogs. Just wanted to give you that update and show you yet another way to use AI to make yourself more productive, even if you want to be the one writing the code. So thanks for watching, and I'll see you next time.